Company Investments in Project Management. This is Chapter 8, Part 2. Following are the learning outcomes from this part. So far, having seen payback period, which is simple, fast, and back of the envelope calculation, and discounted payback, which treats distant cash flows with lesser weightage and more recent cash flows with more meaning, net present value, and internal rate of return. Now we will move our attention to how to apply the concepts of net present value or NPV into real world problems. And later on, we'll talk about profitability index and how to deduce the best project to choose among a number of given projects with all of them have good net present value. So let's recall, net present value is used to determine the worthiness of a project which has a sequence of cash flows, usually which are negative at the beginning, and then one negative cash flow at the beginning and a sequence of positive cash flows. That's usual. That's not necessary, but it's more common. Then we find out the net present value at a discount rate, and these cash flows can be positive or negative. And net present value, therefore, will imbibe the characteristics of the cash flows. So let's assume that we talk about same cash flows. And so if the cash flows are all similar, let's say we buy a machine and then we spend money maintaining it, so all the cash flows are negative. And how about different projects with different cash flows over different periods of time? So these are some of the applications of NPV. So now let's go back to our example. In our example, we were using MKZ Airlines, which was spending $1.5 million for the creation of a new connection, which includes infrastructure costs, etc. So to purchase jets, create infrastructure, etc. The expected cash inflows were $164,220.75, and they were growing constantly by $35,000 per year. And the project was ending in 8 years at a discount rate of 7%. So we were going to find out the net present value, and we found out that net present value as well. Now we also knew the caveat for the net present value function. We should leave out the first or the period 0 cash flow and then add it separately, because NPV function treats the first cash flow as the first period cash flow and discounts it. So for example, the 164,220 should be the first cash flow in the range of the NPV function, and the 151.5 million should be added separately. Okay, now suppose in the same project we had another option, and so we had actually found out the net present value using Excel and also found out the IRR at 9%. So the net present value at 7% was $138,000, and it was positive. So that means the project is viable at 12%. But suppose now we realized that each cash inflow was actually 25,000 higher than previously estimated. And then we decide to, just carry on this new business with bloated cash flows for 4 years and sell the equipment, which becomes more valuable at the end of 1 million at the end of fourth year. So let's call this short business. So to find out the short business cash flows, just title is short business, and then the time period would be the same as the previous time period, 1, 2, 3, but remember only 4 cash flows, and the initial setup cost is the same. However, the new cost is $25,000. The new inflows are $25,000 higher than the previous inflows, and at the end of the fourth period we sell off the equipment at $1 million. So these are the cash flows of the short business. So this was the long business or longer business, only 8 years, and this is only 4 years. So let's call this short business. Now let's find out the net present value at 7%. So equals NPV. Remember, we cannot start with the 0th cash flow. We go from the first cash flow till the end, and then its first argument is rate, and these cash flows plus the initial cost, and then shift control 1 will give us the Alt O C W, enter, control Y, same. Alt O, C, W, enter, Control Y. Good. So the new present value is only $71,000. And here it was $138,000. So short business is seemingly not profitable. Really? We'll see. So $71,000. Now, let's look at the IRR for the two projects. We already know the first project had an IRR of 9%. Now let's look at this project's IRR. IRR is going to be, let's just guess, 0.07, enter. It's not 9%, it's about 8.5%. 8.5%. So the IRR has also gone down, the NPV has gone down. Okay. So that we choose the long project with respect to the IRR decision as well. Now, if we plot a graph at different discount rates, kind of like this here, so equals this, no, NPV, this, comma, fix it. So dollar and $3 colon dollar and $6 plus dollar and $2. Shift Control 1. And then Control D, Control D, Control D, Control D, Control D. Look, it is still between 8 and 9%. The NPV is still between 8 and 9%. And plotting it on the graph will give us the same result. So just select data and just call it short business. X values are till here, let's say. Y values are till here, and then okay. So it's not as complete as a long business, but we still get the graph we want, like the crossover until the cross. Oops. Yeah, enough. This is enough. So this is 8.5% and this is 9%. So looking at the graph, IRR short is 8.54%. IRR of long is 9%. Notice that's where they cut the x-axis, 0, right? So, okay. But these projects are not equal. The first project is 8 years. The second project is 4 years. So we have to find out the equivalent annual annuity or the equivalent payment per year that would make me indifferent between these two net present values. So notice how this project is for 8 years. Its NPV is $138,000. So what we say is PMT. What is that single payment over these 8 years that will make me indifferent between this NPV and my equivalent annual annuity? So number of periods is 8. Then present value is the net present value, which is minus 138. Future value is 0 and type is 0. So what essentially we're doing is we're converting the net present value into a series of equivalent cash flow payments over the duration of that business. So the per year equivalency of that net present value is $23,000. Do the same thing here, equals PMT, that single payment at 7%. For 4 years, it's not 8 years anymore. And then present value is minus 71,000. Future value is 0 and type is 0. So this is 21,153 in green as compared to 23,148 in green. So the equivalent annual annuity of the long business is still more than the equivalent annual annuity of the short business. So all the three methods are giving us the same consistent answer. Do not take the short business, take the long business. But what if this scrap value, instead of $1 million, was $1,005,000? Or $1 million, not 5,000, but 101,010,000. Notice how this net present value, let us mark it in light blue, is less than this net present value. So the short business has still got a lower net present value than the long business in blue cells. But the short business is giving us a better equivalent payment per year as compared to the long business. So in the short business now, we are earning $23,400 equivalently for each year as compared to only $23,100 per year for the long business. So that is what we are trying to find out with the help of the equivalent annual annuity. So this is called equivalent annual annuity. So we select the one which has a longer or more positive equivalent annual annuity. Now this can also be reverse engineered into cost. So for example, if we have two projects, project one, 20,000 produces cash inflows of 40,000 each, we can find out the net present value is minus 364,000. Clearly, all of these cash flows are negative, so they cannot give us a net present value that is positive. And similarly, this one. Now this one has a higher setup cost and a higher maintenance cost, therefore its net present value is higher, and it's also for longer duration. But notice how its per year annual equivalent annual annuity is lower than, so let's just go through these numbers. Its NPV is very large and negative. This project one has a smaller negative NPV, so we would be inclined to choose project one because it's got a smaller negative number. However, project 2 has a smaller equivalent annual annuity. In other words, the annual equivalent expense I make on project 2 is smaller than the annual equivalent expense I make on project 1. That's why we actually end up choosing project 2 because of their unequal lives. So when the lives are unequal, NPV does not give us an exact representation that we're looking for. So the EAA, equivalent annual annuity, or the PMT function is much more powerful for that reason. To conclude, multiple projects can be compared using the NPV method. The pitfalls of NPV method are unequal lives, which we can solve by using equivalent annual annuity or annual benefit or annual cost, whichever side we want to go. It can also be applied to projects with only cost and unequal lives. Coming up in the next part, we'll talk about the pitfalls of IRR, the NPV profile, crossover point, and profitability index. That is chapter 8, part 2. Thank you for listening.